So today we will start with Bash scripting. We will start to build some simple Bash scripts, and of course we are going to use the Vim editor for editing these Bash scripts. And this way we will also refresh some of the things that we learned in the last lesson about the Vim editor. So let me clear some things here first. Okay, I will start with a simple script which I'm calling hello.sh.shell. Now that I am in the Vim editor, I will type I to start editing, and then I'm going to type some text. So first I press I, and then I am typing these commands. The famous hello word. And let's type another command as well. So a Bash script is a file that contains a list of commands. And I type, now I'm going to save this, type escape, and then I also will quit. So this is write and quit. So first escape to go to the command mode. Okay, and now write and quit, and press enter. Now let's look at the command of the content of the file hello.sh. It has these two lines. Now we can send the content of the file through the pipe to the command bash. And bash is the command that starts a bash shell. So it is going to get as input the content of this command. And bash is going to interpret the first line as the first command, because there is a new line, like an enter at the end. And it is going to interpret the second line as the second command. So it is going to execute these two commands, and we get the output from these two commands. So this is one way to execute this script. But we can also call the command bash giving this file as an argument. So bash hello.sh, And again, it is going to take the content of the file and it is going to execute it or interpret it line by line, each line as a command. Now we can do something. We can add something at the first line of this file to tell the shell that this is a bash script. So let's edit it again with Vim. Now I'm going to the first line because the cursor is at the line that we left it when we exited. Now I'm going to the first line with 1G, go to the first line, and then capital O to open a new line above it, and then I will type something on that line. So first 1G to go to the first line, and then capital O, and then I'm going to type this. And now escape to go to the command mode, and then write and then quit later, and then quit. So escape first, and then write and enter. Now these two characters in the first line of this file, this is an hash, and this is an exclamation point. But these are also called she and bang. So this is called shebang. This is called shebang. This is telling the shell that after the thing that is coming after is a command that should be used to interpret this script. So if I am calling it like this, it is going to find out that this the shell is going to find out that this script should be interpreted by /bin/bash, because this is written on the first line after shebang. But if I try to execute it, it is saying command not found. Why it does not find this command? It is because shell, we have set it before, but we can repeat it. There is a variable path which contains a list of paths separated by a column. So these are different paths. And when we type a command on the prompt, the shell is going to look at these directories or at these paths for this command. Is the command in this directory? No. Is it in this directory? No. Is it in this directory? No. And so on. It is going to search all the paths for this command. And in this case, it does not find it in none of these directories, and it gives the message command not found. It cannot find the command that should be executed. To fix this problem, or to circumvent it, to bypass it, we can tell the path where the command should be found. We can tell the shell the path where it should be found. And actually, it is in the current directory, so we can type it like this. Or let me clear first the screen. So I can type the path like this. So when I give a path to the command, then it is going to execute the command in the given path. If I don't give a path to the command, if I just type hello.ssh, hello.sh, it is going to look at the paths in the variable path. So right now it is going to execute the command in the given path. So now look at the path variable. But now it is saying permission denied. Permission denied because it does not have an execution permission. So we don't have the permission to execute this file. The permission to execute a file or a directory, a program, is X. So we don't have the X permission. So we are not allowed to execute this command. And we can give the execute permission with the command change mode plus X hello.sh. And now it has the execute permission, and the files that are executable also are displayed in green by the terminal. And now we can try to execute it again. Now it is executed, and it is executed by the shell script. It is executed by the command bin bash, because this is what we tell it after shebang on the first line. So that's why it is executing it with bash as a bash script. It is interpreting it as a bash script. If it was a Python script, for example, we would write this. For example, and then that script would be interpreted by user bin Python 3, for example. Another way to fix the problem is to add the current path to the variable path. So in this variable, it is not this directory. This directory is not in the list of executable directories, but we can add it to this path, and we can do it like this. We modify the variable path, and then we add the current directory, or I can do it like this. The current directory, and then semicolon, column, sorry, and then path. Now, if I show the variable path, we see that it is going to search in the current directory as well. And so if I just type hello.sh, it is going to find it, because it will look at this directory and it will find it here. But we will continue to execute scripts like this, because this is more convenient. So we are just giving a path in front of the program that is in front of the script that we want to execute, and so it will skip looking. The shell will skip looking at the directories in the path variable. So this is the first script. Now in bash scripts, or in the shell as well, we can use comments by this. So everything that comes after hash is a comment. So the shell will not try to interpret or execute this. So everything after an hash will be skipped by the shell, and we can use comments in a script as well. So let's try to add some comments to this simple shell script. I will type lowercase O to open a new line after the first line, and then we'll type a comment. So lowercase o. It is adding automatically this hash, but even if it was not added, then I can type it. And let me type escape. Let me go to the first line with capital G. I press capital G, go to the last line. And then I will append some text to the end of the last line with capital A. Capital A. And then escape. And then write, W, write. So a comment can be on a line of its own. So there is just a comment in this line, or it can be in a command line, and everything after this after this character, this hash, is considered a comment, and it is ignored by the shell. So let's try to execute. Let's try to execute this script again and make sure that the comments do not have any effect on the output of the script. So they are just ignored by bash. Now we will start a mini project. We will start a mini project to write a script that generates a report about various status and statistics of the system. And this report will be in HTML format. But before this, let's get some example files. We will download them with the command wget. Let me create a directory examples. Let me go inside this directory. And then I will download an archive file that contains the examples for this lesson. wget https linux command line interface.fs.al, and then examples, and then lesson 10.tgz. And this is an archive file, a tar archive, which is also zipped. And we know how to extract the content of this archive. We can do it with the command tar extract, and then z, and then f, and then the archive file. And it has extracted the content of the archive in this directory. Let's go in this directory because here there are some example scripts that we are going to use in this lesson. So here there are some example scripts that we will see later, but there is also this example HTML page. So let us look at the content of this file. It is a very simple HTML page. We have a head and then a body, and inside the head we just have this title. Now we want to create a bash script that generates a page like this. So let's rename this to another to be a script. Move page.html. So we want to call a script that we are going to write system information.shell. And now this we are going to make this a shell script. So let's open it and edit it. Synsinfo.shell. Now I'm typing capital O, and I will write the shebang here, which shows that this is a shell script. So capital O, I'm opening a line above the current line, and then this is the line that it is marking this file as a shell script, which should be executed by bash. And then escape to go into the command mode, and then write. So I did an escape and then write. And now I want to, I am going to use the echo command to output each of these lines. So let me type it. Let me type it here first. So I'm going to give a command, vim command. So this is from the second line to the last line. So this is a range of lines. Substitute. This is the beginning of line. So at the beginning of line, I will place this echo and an opening double quote. And then later I will put a closing double quote as well. So from the second line to the last one, substitute, beginning of line, and then enter. So you see that each line now starts with this, but we want also to close with a double quote, a double quotation mark each line. So I can do this with substitute. Now at the end of line, I'm going to place a quotation mark. So let's do it here. From the second line to the last one, substitute. At the end of line, a double quote, a double quotation mark. So we see that we have converted each line into an echo command, and it is going to output each line of the HTML file. Let us test this script. So escape, actually we are in the command mode, and then quit. We have to write first, write and quit. W and Q. Now we see that this is still not executable. In order to test it, we have to make it first executable. So change mode +X synsinfo.shell. Now it is executable. Let's try to execute it. Sysinfo.shell, and it is outputting the content of the HTML file. Now we can redirect the output of this script to sysinfo.html. And let us check the content of sysinfo.html. It is this HTML file. And actually, we can use a command line browser to view the content of an HTML file, like LineX. LineX is a command line browser. sysinfo.html. So here we have the page title, and here we have the page body, and it is an empty page actually. So this is what we can see, nothing else. We did not expect to see anything else. Now to exit from this LineX, I type Q, and then it is asking, are you sure you want to quit? Yes, I type yes, and I exit from LineX program. Now let's add a comment on this script. So we edit it again, vim sysinfo.sh, and I'm at the last line. So let me go to the first line with one capital G, and then I press lowercase o to open a new line below the current line, lowercase o. And now I can type a comment. Program to output a system information page. And I'm leaving an empty line here. Let me save the script so far. Now we can improve these lines by using a single echo. So instead of using echo for each line, we can just use echo, open the string with a double quotation mark here, and then close it with a double quotation mark at the end. So I want to delete this echo and so on up to the last one, and I want to delete this double quotation mark up to this one. I just want to leave this one. So let me move with J to the line below, and now I can use a command like this: $, substitute with nothing. So I'm going to substitute this with nothing, empty string. So I'm just going to delete this one. And I'm starting from the current line. This dot means the current line, from the current line to the last line. So let me try it here. From the current line to the last one, substitute echo and a double quotation mark with nothing. And I'm pressing enter, and you see that all of them are deleted. Actually, I deleted the first one here. So let me undo with you. So let me press another J key to move to this line. So from this line up to the end, to the last line. I don't want to delete the first echo. So again, I press the up arrow key to get the first command. So with the up arrow, I get the previous command. And now I press enter. And Now let me go to this echo again, to this line, and I can go to that line by pressing this slash and then echo and then enter. So it is going to search for this word, and it is going to go to this line that contains this word. So here I press slash echo and then enter. So I'm searching for this word, and I'm placing the cursor at this line. Now I want to delete this closing double quotation character for each line except for the last one, and I can do it like this: from the current line up to the last line -1. So this is the line before the last one. So this is the last line. This is the line before the last one. Substitute this double quotation mark at the end of line with nothing. So let me try this command here. From the current line up to the line before the last one, substitute this double quotation at the end of line with nothing. So I just removed the last quotation mark from these lines, and I left only the closing quotation mark for the last line. So this is opening a string, and this is closing a string, and this is a string, and it contains new lines at the end of each line, and that's fine. And let's see how whether this works. So write and quit, and then we try it. This simple, and so we are getting the same output. Up to now, the output from the script is just an empty HTML file. Now let's try to make it to output something. So again, we edit the file, and we edit the script. And now I want to replace this page title with the real title of the page, which is System Information Report. So let me type replace in the whole buffer page title with System Information Report, and then enter. And I replace this with System Information Report. Now I want to replace this page body with first heading, which is H1 in HTML, and with the same System Information Report. So replace in the whole buffer. No, in the whole buffer, replace page body with H1 System Information Report, and then close H1, and then close. But now I have a problem because this is inside the string that want to replace, and it can be interpreted as the end of this substitute command. So let me press Control A. No, it doesn't work. So let me move back and change this delimiter character to something else. For example, I can use this as a delimiter character, and the same here, and the same delimiter character here. And now I have this heading one, header, which is like the title of the report. And actually, there is a missing space here. And I'm writing it. Now, let's see how to use some variables, because here we have the same string, system information report, system information report. It is a string that is repeated. And we can avoid this repetition with a variable. So I'm going to replace this with a variable. Again, from the first line to the last one, substitute system information report, system information report with title. So this is the variable title. So I'm using here a variable title, which is going to be expanded by the shell, but I have not defined yet this variable title. So let me go and define it here above the echo line. So I'm locating this. I'm going to this line with slash echo and then enter. And then I will open a new line with capital O. Capital O, open a new line. And then I will type title. And then system information report. So, and write it. So I'm defining a variable here with this, which has this value. And now I'm using this variable for the title and for the heading of the report. So let us test this script so far. Execute it. And let us save it to this info.html. And we see here system information report, and here is the heading system information report. Let's quit with Q from line X and then Y. And we can continue improving the script, but first let's see some more details about variables. In Bash, we declare a variable like this. So this is the name of the variable, and this is the value of the variable. And it is important not to include spaces around the equal sign. So these spaces are not okay. So in another programming language, for example, in C or Java or every other programming language, spaces can be used freely. There is no problem, but not in Bash, because Bash interprets spaces, is using spaces to separate arguments from each other. So there should be no space around the equal sign. And to get the content of this variable, for example, use it for echo, we use a $sign in front of the variable name. So this is the variable name, and with the $sign we get the variable value. And actually we have a shell extension here, and which is passing a yes to the command echo, and it is printing this yes. And what happens if I say echo foo1? Now this variable foo1 is not declared. We have not declared it. We have not given any value to it. But Bash does not complain about it. It is a missing variable, but Bash it tries to find this variable. It does not find such a variable, and it assumes that it is empty. It assumes that this variable has an empty value, no error message, etc. This can be a problem sometimes, so we should be careful because we may mistype, for example, the name of a variable. For example, if I create a file, a test file, and now I place the name of this file in a variable. For example, variable foo. So in this variable foo, I have the name of this file. In this variable, we keep the name of this file. And now, let me say that in variable foo1, which is another variable, we keep this other variable. And now I want to rename foo.text to foo1.text. And I can do it like this. Move foo1. So this contains the name of the existing file. And this variable contains the name of the new file, which would be this one, foo1.text. But let's say that we mistype it, and instead of 1, we type L, which is a common mistake because they look very similar sometimes. So 1 and an L looks very similar. So now we have a variable that does not exist, but shell does not complain about it. Let's see what happens. Now it is saying missing destination file operand after foo.text because shell is replacing or is expanding this with foo.text, and then it tries to expand this variable, but it does not exist. So it is expanded to an empty string. And so this command is the same as typing move foo.text and then nothing, empty. And there is no destination in this case, and this is what the error message says: missing destination file after foo.text. And this problem is arising from the fact that shell does not complain for a non-existing variable. If we use a variable that does not exist, it just assumes that it is empty. So we should be careful in some cases to avoid mistakes like this. Now let's continue with the script that we started. Let's continue editing this shell script. And it will be more appropriate to use a constant in this case for the title instead of a variable. And in Bash, by convention, we use uppercase letters for the name of a constant. So let's convert this title to uppercase letters. And I'm going to replace in the whole buffer this title with capital title. And now I have to substitute or to replace this one with capital letters. So again, in the whole buffer, substitute title with capital letters title. So this is being used as a constant. A constant is like a variable, but once we assign a value to a constant, it should not change again. So actually, this is a convention, because we still can change the values of this variable, but to indicate that it should be a constant, we are using capital letters. It is also possible to make sure that this is actually a constant, and we can do it. We can do it by using declare. So we can declare a variable by using the keyword declare. So let me type I to insert here, I, and then declare minus R. So this declare is declaring this variable, and this option minus R means read only. Read only means that once we assign a variable, a value to this variable, it cannot be reassigned again. So we can not assign another value, which is basically a constant. So now we have this one. Now we made it a constant. And let's improve the title a little bit. So I'm going to the end. I am appending to the end of the line. And with arrow, it is also possible to move with arrows. So now it says system information report for host name. This host name is a shell variable or an environment variable. So let us check what is its value. And it is the name of the current host or the current system, which is this one. So if we execute this script, now it is saying system information report for the current host, for this host name. Now, when we can also assign multiple variables in a single line. For example, A equal 5 and B equal so in the same line, we assign this variable A a value and assign another value to the variable B. Echo A, echo B, and it says a string. When we do a variable assignment, shell extensions are applied first. For example, echo B. So B has this value, a string. Now, if I say variable C gets the value is B. Now this $B is expanded by the shell to replace it with the value of this variable before the assignment is done, and so the actual value of C is this is, and then the value of this variable, which is a string. So shell expansion is applied first, and then the assignment is done. The value is assigned to this variable. And also shell expansion is also done in cases like so. Before the assignment is done, the shell is expanding, is executing this command, and the output of the command is assigned as a value to this variable. So the value of this variable is actually the output of this ls command. And the same applies also for arithmetic expansions. For example, this variable e gets this value, and here we can include an arithmetic expansion, for example, expression. For example, the value of variable e is actually the result of this arithmetic expression. And let's see another example with escaped characters. This /t/t usually is interpreted as tab. And then this /n or \n is usually interpreted as a new line character. And if I just try to output the value of this variable f, we get the content of the string, because this is all interpreted as a string. But if I use the option -e, this is going to interpret this as escaped characters. So as a special character, this is a tab, and this is a tab, and this is a new line character. So in this case, we get a tab, and then another tab, and then we get a new line character at the end. So actually help, because echo is an internal command. So this option -e is enabling interpretation of the following backslash escapes. So these are the backslash escapes. With \t, we have an horizontal tab, and the \n, we have a new line. So it is interpreted as a new line. Now, when we get the value of a variable, for example, echo, let me clear the screen first. Echo a, we can also surround the name of the variable with this curly braces. So the result is the same. And sometimes it doesn't matter whether we use the curly braces or not. So this is more easy to write. But sometimes it does matter. And let's see an example when this is important. It is important to use these curly braces to delimit the name of the variable. For example, let's say that we have a variable called my file. Now, if I say touch file name, Now it is going to be touch my file because the value of this variable is my file, and it is creating this variable my file here. But now let's say that I want to rename this file to myfile1, and now I can use the command move, and then file name, and then file name 1. What I want to do is I want to rename this my file to myfile1, but let's see what happens. It is saying missing destination file operand after my file, and this is happening because this variable name file name 1 does not exist, and the shell is replacing it with an empty space. So the command is just move my file and then empty space, and it is giving this error message. What we should have done instead is to delimit the name of the variable with these curly braces. Now it is clear that this one is not part of the variable name. So the variable name is file name, and this one is something that is appended to the variable name. And now we get the correct result. So from my file, now it is renamed to myfile1. Now let's see how to output some more information on the report. For example, we can add the timestamp of the report, etc. We can get the timestamp using the command date. Timestamp means the time of report generation. So the time that we generated the report, or the time that the report is generated. But let's change the format of the output. So we are going to use this command to generate the timestamp of the report. And also, let's use, we can use the environment variable user, which shows the current user that is logged in the system. So let's keep editing the report script. And now the cursor is on this line. Let me type capital O, and then I will enter some more code. Current time. I'm going to execute that command, date. And now press enter, and then timestamp another variable. I'm declaring another variable, or defining another variable, timestamp. Generated on current time by user. So this variable current time is being defined here above, and it is getting the current date. And this user is the shell environment variable. which contains the name of the current user that is logged in to the shell. And now I'm going to add this timestamp. As a paragraph after this line. So let me press escape to go to the command mode first. And then in order to go to this line, I will press, I will type /h1 and then enter. And I will be positioned to this line. So let me try /h1, enter. Now that I'm on this line, I can duplicate this line by typing capital Y. Capital Y is the same as YY, which is making a copy of the current line. And then I will type P to paste it below. So capital Y and then P. Now I can change this H1 to a P, which is a paragraph. So I want this to be a paragraph. And I can do it with a command like this. Substitute H1 P global. P and then global. So every occurrence of P1. And this is going to substitute only on the current line. So I'm not giving any range. So usually I will say from the first line to the last line. But if I don't give any range, then this is going to operate on the current line. This command is going to operate on the current line, which is this line. So substitute H1 with P global. And now this is a paragraph. And now instead of title, I want to have this timestamp. And I can do it again with substitute title with timestamp, and then enter. I can also move with arrows, and then I can press I, and then I can edit it. But just to show the usage of these Vim commands, I did it this way. So let me save, and let me try this script. Let us try this script and see what does it produce. How does it work? Info. Here, this info. So here is the title, and here is the time stamp generated on this date by user one. And let's save it to the HTML file. Let's check it with Linux as well. So here is the timestamp generated on this date by user one. Now quit, and then yes. And let's stop here this lesson, and we'll continue with improving the script in the next lesson on Tuesday.